Distributed the exponents, and what was your final answer?
5 to the 6th power x to the 4th y to the negative 4th over 5 to the negative 4th x to the 4th y to the negative 6th.
And is that your final answer?
No.
Okay, so what's your very final answer?
Oh, I haven't got
Oh, you haven't gotten that far yet? Who's got a final answer for me?
I got 16,250.
That's too much.
25y2 or 25y squared.
20, I did not get 25y squared. I got 25. Keep working. I'll give you guys a minute. Isaac, what'd you get?
5 squared x to the 8th power and then y to the 10th power.
That's what I got. I didn't write it as 5 squared. I turned that 5 squared into a
25.
25. But yeah, that's what I got. 25x to the 8th, y to the 10th. So let's look at that. Okay, so Will told us he got, Will, you said that you got 5 to the 6th, x to the 4th, y to the negative 4, right? 5 to the 6th, x to the 4th, y to the negative 4th over 5 to the negative 4.
Shouldn't it be 5 to the 10th?
It should be 5 to the 10th. We're going to talk about that. I think that I want this to be a positive is what I originally wrote that down as. X to the negative 2, y cubed. I think you're right. Okay, so 6 minus a negative 4 becomes what? 6 plus 4?
5 to the 10th.
So that should be 5 to the 10th. X to the 4th, did I distribute that? That should be a negative 4, sorry. 4 minus a negative 4 becomes 4 plus 4, or 8, right?
Wait, shouldn't it be x to the 4?
Yeah, I'm so sorry, you guys. I'm just... Is that better? I'm erasing all this. Let's try it. Try again. 5, distribute. 3 times 2 is 6. X times 2 is 4. Negative 2 times 2 is negative 4. Over. 2 times a negative 2 is negative 4. A negative 2 times a negative 2 is a
4.
Positive 4. And 3 times negative 2 is
Negative 6.
Negative 6. I had that x, when I wrote the problem out, I left this as a positive exponent. That's why. So I think you're actually right. 5 to the 6th power minus a negative 4. Minus a negative 4 is the same thing as plus 4, so that becomes 5 to the 10th. 4 minus 4 is?
0.
Anything to the 0 power is?
1.
Okay. Negative 4 minus a negative becomes negative 4 plus 6, which is 2, right?
Mm-hmm.
So 5 to the 10th y squared, which is, what did you say 5 to the 10th was? Someone rattled that out. Like 16 million, something, I don't know. Okay, I don't know. We're going to leave it like that. Okay, so how have you guys been doing with that? So? Not so good? Okay, let's look at our homework from last night. So this was your lesson 1, 7.1 and 7.2 review. I tried to show my work as much as possible, but we'll talk about every single problem. So for number 1, first of all, here's what you need to notice, that the 6 is the only thing that's being raised to a power, not the negative. We learned that at the beginning of the year. The only time that you're going to raise a negative to a power is if it's like this, right? That would be negative 6, the quantity raised to the negative 2 power. If I don't have the negative sign in front of this, in the parenthesis, including that number, then that negative is not included. Do you guys see that? Okay, so I have a negative 1, and then I dropped my 6. I wrote it as 6, so 1 over 6, right? Because the only way to get rid of that is to reciprocate it. So this is 1 over 6 squared, but it's negative. So negative 1 over 6 squared. 4 squared is the same thing as 16. So I have negative 1 times 16, which is negative 16 over 36. I divided both top and bottom by 4, and I got negative 4/9. Thumbs up if you got that. Okay. Does it make sense if you didn't? Okay. Here we're going to distribute the power. Negative 8 times negative 2 is a positive 16, so you should just have f to the 16th.
Yeah.
Okay. Number 3. So here's what I want you to think about whenever you have negative exponents. I always draw a fraction bar. So I'll just work this one out with you again. I draw a fraction bar. This is not raised to any power, and this is a positive exponent. I'm going to put it in the top. R cubed. This is a negative exponent. The only way for me to make it positive is to move it down. Move it downstairs. Q squared. Negative 2. That doesn't get raised to any power. So times negative 2 times R squared times a negative. That's a negative, so I need to move it down here. Then use the rule. Bring that negative 2 out front because you always want your constants in the beginning. Base is the same, add the exponents. 3 plus 2 is 5, so I have negative 2 r to the 5th. 2 plus 4 is 6, over q to the 6th. How do we do on that one?
Good.
Good?
Oh, did I do good? Yeah.
Number 4, same thing. I drew a fraction bar. Start a fraction bar. This is a negative exponent, so I'm going to drop it positive. P to the 5th, move it downstairs. Q to the negative 2, move it downstairs. It becomes q squared. I distributed p 2 to the 4th power. That distribute that power becomes p to the 8th. Then I'm going to use my quotient rule that says if the base is the same, I subtract. 8 minus 5 is 3, so I end up with p cubed over q squared. How are we doing?
Good.
Good? Number 5, c cubed. D to the negative 3, I dropped it. Moved it down to make it positive, d cubed. F squared, negative f to the 0 power. Anything to the 0 power is 1, so this is essentially saying negative 1. So all I did is I moved this negative out front, so I end up with negative c cubed f squared all over d cubed. Good? Okay, number 6. So this 2, this negative 2 is being squared because it's all together. Okay, so the first thing I did is I distributed that. 2 times 3 is, so I have negative 2 raised to the 6th power. I have to distribute this negative 2 right here. Let's see. I have to make this a positive exponent, and the only way I can do that is by doing what? Dropping it downstairs. So this is the same thing as 4x squared raised to the 2nd power. Now I'm going to use my rules. Negative 2 to the 6th power is 64. I'm going to distribute this. 4 squared, x to the 4th. I know that 4 squared is 16, so I have 64 over 16x to the 4th. Reduce. I end up with 4 over x to the 4th. How are we doing?
Good. Good.
Good? This is hard enough as it is, especially when your teacher's not here for 2 weeks to show you. Okay, negative 2 is my constant. I pull it out front. A squared. I pull this 8 out front, so I have negative 2 times 8. A squared times a cubed. The base is the same. I'm going to add the exponent. So negative 2 times 8 is negative 16. 2 plus 3 is 5, so negative 16, a to the 5th. How are we doing?
Good.
Okay. Number 8. First thing I'm going to do is distribute this power. I'm going to rewrite this as 4 squared x to the 4th times 5 to the negative 3 x to the negative 6 times negative 1. All right. Well, 4 squared is 16, and I multiplied it by the negative 1. Do you guys see that? So I have negative 16 x to the 4th. This 5 is raised to a negative power, so I'm going to drop it to make it 5 cubed, which is 125 x to the 6th power. Now look, can I reduce these two?
Yeah.
No, these two can't reduce. But the x to the 4th, x to the 6th can be reduced. So I end up with negative 16 over 125x squared. How are we doing? Has anyone gotten the first 8 perfect? Well, awesome, awesome, awesome. Very good. Okay, number 9. So I'm just going to use the rule. A to the 5th, b to the negative 2 minus the negative 4 is negative 2 plus 4, right? C to the negative 3, I'm going to move it upstairs and make it c to the positive 3. So negative 2 plus 4 is 2. So you should end up with a to the 5th b squared c cubed. Sir.
See the answer to number 8 again. I messed it up and I'm trying to correct it.
Yep. Number 10. So 3 and 15 reduces to 1 and 5, right? Negative 2 minus 1 is negative 3. So I'm going to move that downstairs. Do you see how I moved this negative down here and made it positive? 3 minus 1 is 2. So I have y squared up top, 5x cubed in the bottom. Y squared over 5x cubed. How are we doing? Are we good to go to the next page? Are you guys going to need more practice with this? Yeah.
Yeah.
Okay. Number 11, let's see. So we're going to distribute the power first. So this becomes 3 to the 3rd power, a to the 6th power, b to the negative 9th power, over c to the 9th. I need to take this negative and move it down to make it positive, right? So I end up with 3 to the 3rd power, which is 27, a to the 6th, all over b to the 9th, c to the 9th. Okay. Number 12. Number 12 is interesting. I tried showing you this. You can automatically distribute the power, but sometimes if you have the same exact terms in the numerator and the denominator, just reduce that before you distribute the power. Look, h squared, or h to the negative 2, h to the negative 2, that reduces to what? 1. Yeah, 4 over 4 is 1. H to the negative 2 over h to the negative 2 is 1. G over g, that reduces to
1.
So I really have 1 over j to the negative 2 power. How do I make that positive? Because I can't leave a negative exponent. Reciprocal. What's the reciprocal?